We know how to add two rational numbers. We have learned this thing. But what if we have more than two rational numbers? Like in this problem, we have 1, 2, 3, and 4 rational numbers, and we have to add them together. If you're thinking that 1 is not a rational number, then we can write 1 as 1 over 1. Now this is a rational number, right? So if we have to add 4 rational numbers, then we can solve it using two different ways. The first way will be, not the first or second way, but let's say one way will be to apply the property of associativity, right? Associativity. Now, what does associativity tells? We have discussed this, that if we have three uh, rational numbers that are added, let's say a, b, and c, then this can be written as a plus b plus c. This will be equal to a plus b plus c. Can you see here? First we are adding a and b together, then we'll add c to the result that we'll get from a plus b, that is a sum from a plus b. But in this case, you first add b plus c, you get the sum, and then you add the sum to a, right? But the result will always be the same, whether you follow this one or this one. That's what associativity tells us. So if we apply associativity in this case, then we can write it as 1 over 1 plus 2 over 9, like you can associate in different ways, plus 7 over 3 plus 11 over 27. Right? What all we have done is just we are putting brackets here. So this is associativity. Now, if you follow this path, right? If you follow this associativity path, then it will take it will increase your number of steps. And the reason why I'm saying is when we'll solve this problem, and I'll show you why I'm saying that it will increase your steps. So you'll ask them, what's the best way to solve such problems? And second, should we not consider this associativity property? Yes, we should, because when you will move further in your class, when you'll move into next higher standards, then we'll have different complex problems where we'll have to use associativity, where we'll have to use commutativity, closure property and all. So you should consider this. But in this scenario, if you have to simply add 4 rational numbers, follow the second path. And the second path is very simple. Simply, what you have to do is first take the LCM of the denominators together. So if you take the LCM of denominators, then LCM of 1, 9, 3, and 27 will come 27. Okay, now for this 1 over 1, if I want the denominator equal to LCM, that is 27, then this is 27. If you divide 27 by 1, the quotient will be 1. So, sorry, the quotient will be 27. So this becomes 1 times 27. And we have learned all these things, why we do this and how we do this. In this case, if you want the LCM as 27, if you divide 27 by 9, you get 3 as the quotient. So 2 times 3 will be the numerator, plus this is 27. If you divide 27 by 3, you get 9 as the quotient, then 7 times 9, plus here we already have 27. So we need not to multiply anything in the numerator. Now this becomes 27 over 27 plus 6 over 27 plus 63 over 27 plus 11 over 27, right? And now we have the same denominators, so simply write 27 here. This is 27 plus 6 plus 63 plus 11, and you get 27 plus 6 is 33. This gives us 96, and this gives us 107 over 27. So this is the answer for this one. If you want to solve this one, let's do this. This is 1 over 1 plus 2 over 9. If you take the LCM of 1 and 9, you get LCM as 9, right? LCM of 9 will be 9. So in this, if you want the LCM to be 9, then we'll have to multiply this numerator with 9. Plus, it's already 9, so simply write it here. Then plus, in this case, you have to find the LCM of 3 and 27. So the LCM of 3 and 27 is 27. If you want the denominator as 27, so 27 divided by 3 is what? The quotient is 9. So we'll have to multiply the numerator with 9. Plus, this is already 27. This gives us 11. Now, in this one, you get 9 over 9 plus 2 over 9 and plus 63 over 27 plus 11 over 27. This gives us 9 plus 2 plus 27, 63 plus 11. This gives you 11 over 9 plus 64, 74 over 27. Now can you see that we already have calculated LCMs 2 times, one for this one for this one. Now again you'll have to calculate LCM for 9 and 27, right? Though it's very simple, the LCM of 9 and 27 is 27 only. But the point is, you can see that you actually calculated LCM 3 times here. But in this case, it was only once, right? So now you'll again find the LCM. So of 9 and 27, it's 27. So this will be 11 times 3 plus this is 27, so 74. This gives you 33 over 27 plus 74 over 27. 27, 33 plus 74, and this gives you 107 over 27, right? Answer, this is equal to this one only. But you can see we have to calculate LCMs 3 times. That is why I was saying that it increases your number of steps. And that will be more clear when you'll see here. This is 1 over 4 plus 7 over 16 plus 9 over 2 plus 5 over 8 plus 6 over 32. Here we have 5 rational numbers. So if I apply the one way, that is the associativity one. So in this case, I can put 1 over 4 plus 7 over 16 in one bracket, then plus 9 over 2 plus 5 over 8 in one bracket and plus 6 over 32, right? Now you can ask, can't we do like this? Can't we put 1 over 4 plus 7 over 16 plus 9 over 2 and plus this one, the pairing 5 over 8 plus 6 over 32. Can't we do this? Yes, you can do this. Right? So doesn't matter whether you follow this one or this one, you're going to get the same result. But look here. First you'll find the LCM of this case 4 and 16. You'll get some result. Let's put it R1. Right? That will be a rational number. Then again you'll find the LCM of this one. Let's put it as plus R2. Then it is plus 6 over 32. Right? Now again you'll have to apply. Let's say that this comes as P over Q and this is A over B. This is P over Q plus A over B. Right. Now again you'll have to apply associativity. So it means you can either pair this one or you can pair this one. Right. You're going to get the same result. But again you'll have to find the LCM of this one. You'll get again a rational number. Let's say that is C over D. And here already we have P over Q. Then again you'll find the LCM of Q and D. That is why I was saying that if you follow this path, it's going to take a lot of steps. Then what's the best way? Best way is always take LCM in one shot, in one single shot, and then you can find the answer. So LCM of 4, 16, 2, 8 and 32 will be 32, right? Now, will be 32. Now, if I want the LCM in this case as 32, so 32 divided by 4 will give you the quotient as 8. So this is 1 times 8 plus, if we want the denominator as 32 here, so 32 divided by 16 gives us 2 as a quotient, so 7 times 2. This is, if the denominator is 32, 32 divided by 2 is, the quotient is 16, so this becomes 9 times 16 plus, if we want the denominator 32, then 32 divided by 8 gives us 4 as a quotient, so this is 5 times 4 and plus, it's already 32, so no need to multiply anything to the numerator. This is 8 over 32 plus 14 over 32 plus 144 over 32 plus 20 over 32 and plus 6 over 32. Now the denominators are the same, therefore 32, 8 plus 14 plus 144 plus 20 plus 6. 8 plus 4 is 22. This gives you 166, 186, 192. So answer is 192 over 32. Right? So by following this path, that is taking LCM in one single shot, we can clearly see that it has reduced our steps significantly and our calculation has become much easier in comparison to what we would have done in the case of associativity